Good afternoon. Today we're going to talk about the agricultural innovation known as vaccines. Prior to vaccinations, farmers often had to quarantine and kill when their herd was exposed to a disease. Now this can lead to devastating losses because not only are you killing the infected animals, but you're also killing the healthy animals as well. This is the only means for eradication and prevention of spreading of the disease. Let's begin by talking first about what is a vaccine. A vaccine is a biological agent that provides immunity to a particular disease. This can often involve a killed or weakened microbe and can be used as a prophylactic or a therapeutic. Prophylactic meaning it prevents the disease. A therapeutic means that it is treating the onset of a disease. How does a vaccine work? A vaccine is designed to be a destroy and remember cycle. In other words, once the antigen is introduced into the body, here's a picture of what's that like. Once the antigen is introduced into the body, this is as a result of a weakened or killed virus, it will have antigens along with it. The antigens then force the body to produce an antibody. As you can see in this flow chart, once the antibodies are introduced to that disease again, like for example in the future, then they will play a role in sparking the memory cells, such as the memory B or helper T cells, to fight the infection. So basically a virus is designed to stimulate your immune system to remember the fighting techniques when it comes in contact with that disease again. Now, what is known about vaccinations as far as the origin and the beginning of that in both animals and humans? As far as animals were concerned, records indicate that as far back as the 16th century, African tribes were known for inoculating their animals. They were even known in some communities as the healers, as a result of their animals becoming exposed to one another and developing a resistance. Little is known about how they did that in the 16th century, but in the 17th century, documentation shows that French sheep herders often used a serous fluid injection under the skin to prevent smallpox. Now, smallpox was known as like a lumpy type disease that sheep were exposed to and then died from as a result. These pustules were developed and secreted some sort of serous fluid. They collected that serous fluid and injected it under the skin. As far as human inoculation, records show that as far back as the 10th century, that China was involved in inoculating for smallpox. Now the way they did that was they scratched the pustule and inserted some of that serum into the noses of children, and the antigen was absorbed through the mucous membrane, and inoculation was developed as a result of that. So, kind of give us some history on that. Now, as far as the prevention of the virus goes, the prevention of vaccines go, there was a doctor known as Edward Jenner, and he just in the community found that a milkmaid was being very boastful about the fact that she could not collect smallpox because she had already been exposed to cowpox. As a milkmaid and being around the cattle, she developed a resistance to smallpox. She currently had the cowpox pustules though, and Dr. Jenner decided that he would do an experiment with that, and kind of the same along the same lines of what the Chinese culture had done as far as trying to inoculate children, and the fact that he scratched the pustule and exposed the small child. He noticed after doing that, after the child was exposed to the cowpox disease, which which the milkmaid had had, that the small child did not end up getting smallpox, which was the first time to prove that an animal disease could cause inoculation in a human. From that point on, they took lymph from cows and inserted it into small children, mainly because their resistance level was a little stronger than an adult. and then went from arm to arm as far as treating children. In the 1850s, they actually established breeding centers for cattle with smallpox, and they took the cattle and transferred them from village to village, withdrew the limp, and treated the people. So this kind of became the beginning stages of the vaccine. However, it wasn't until the world-famous Louis Pasteur that we actually created a vaccine as a result of a weakened strain of that particular culture. In 1888, Louis Pasteur worked on something known as the fowl cholera and developed a vaccine as a result. Now, the legend goes, this is pretty interesting, the legend goes is that his assistant left for the holiday and left a strain of cholera in a flask, and apparently during the holidays that strain became weakened. When the assistant returned, they decided to treat the chickens, healthy chickens, with a fresh batch of the culture and the aged batch, or the batch which was left over the holidays. Now, if you look at this picture, you can see that the aged batch, which actually would have been the weakened version of the culture, was given to a healthy chicken. That healthy chicken developed antibodies and became free from cholera. In the fresh batch, which would have been the non-weakened version, the injected chicken was not free from cholera and as a result died. This helped him understand, or this helped Pasteur understand, that in order to develop a vaccination or a vaccine, we needed to work on either heating the culture, aging the culture, or killing the culture altogether. And from that point, vaccines took off. Today, vaccines can be administered via subcutaneously, which means under the skin, intravenously, which means in the vein, intramuscular, which means in the muscle, or intranasal, which means through the nasal passage. There has been research done on vaccines that are given intrauterine, which means they are given in the uterus to the offspring. And then after the offspring is born, they check to see the resistance as a result of that vaccine. Vaccines are commonly used in livestock, companion animals, as well as humans. Now, let's talk about some characteristics as far as the vaccination goes, and moving that from an idea to implementation in our society. When you look at if a vaccine has a replacement, when you're talking about the naturally acquired immunization and the exposure to the development of memory cells as a result of being exposed to the disease, then you do see that, yes, it can replace that. In other words, it is keeping us from suffering and experiencing death, or keeping the animal from suffering and experiencing death as a result of being vaccinated or inoculated, versus being exposed to that and then hope that we don't die, that the animal doesn't die as a result. So in that case, yes, it does have a replacement. However, when we're talking about passive immunity, and this is where you're getting antibodies from the mother, that is a very short-lived, maybe 3 to 5 months immunity. It does not replace that. So you will see vaccinations needing to occur within 3 to 5 months afterwards. However, just in general, when we're talking about replacing the idea of suffering and loss to animals, yes, it can be a true replacement as exposed to the natural way of inoculation. Okay, let's talk a little bit about adoption rate. In the 18th century, they were still using just the serum injections only. In other words, no stored vaccination had occurred yet. So just simply going off of serum being produced or being drawn and then injected into the animal, The adoption rate in the 18th century was 3,000 animals per year. That was in France. As far as the human adoption rate, that skyrocketed. For example, just some interesting information. The minute it was discussed as far as smallpox inoculation, the U.S. president wanted a vaccination. The Tsar of Russia wanted and the vaccination. Napoleon not only wanted it, but ordered it for his army as well. There were some people that were reluctant to adopt as far as the idea of using children as a reservoir for creating more serum to go from child to child. So the use of cattle and the length of cattle was continued to be being used. Now, because cattle were often considered as an item of honor in Indian cultures, they faced a socioculture problem when it came to accepting it and adopting vaccines as their, as a rate of an adoption. That was very slow in those kind of cultures. Okay, as far as the 19th century, the roles kind of became reversed. Interesting enough, as we used cattle to create the human vaccine for smallpox, in the 19th century, humans that were exposed to TB, we could actually take that serum and inject it into cattle to create an antibody against the an antibody against the disease tuberculosis. And so because of that, we actually saw adoption rates increase in animals. Also, the fact that we were developing vaccines that were inoculating for PPLO, that Pasteurella pneumonia, and Mycoplasma. But the biggest part of adoption rate for humans came about in the intranasal vaccines. And bless his heart, this little kid is adorable, but you can see that he is struggling with taking his shot, as most Americans would. And as that intranasal vaccine came about, you could see that there was a quicker adoption rate for that route. Of course, when the 20th century hit, more and more vaccines started coming about. For example, West Nile, foot and mouth disease, and naturally the animal adoption rate soared. Interesting enough, and one of the reasons why I wanted to choose this particular innovation is because in the 20th century and the 21st century, we really started to see a halt in our adoption rate, or a decline in the adoption rate as far as humans were concerned with vaccinations, largely because of the autistic scare and how the media caused a scare in the fact that they were trying to link, or it was linked that the three-way vaccine for like measles and mumps were directly related to the onset or the cause of autism. And so because of that, you started seeing many parents opt to not get their child vaccinated, or get their child vaccinated at different times than the recommended, than what the medical association was recommending. And so because of that, I thought that was pretty interesting how we see adoption rates fluctuate as a result. Okay, let's talk about characteristics of this particular innovation. As far as the compatibility, the fact that you do have the animal and human strains are similar. For example, when we talked about tuberculosis or smallpox, we were able to take strains from one or the other and develop a vaccine for the other as a result. Also, what makes it compatible is that zoonotic diseases, which are diseases that can affect both humans and animals, can use the same vaccination. Another thing that makes vaccines compatible in animals is the fact that it's interchangeable among species. Now, this is not always the case, but an example would be like CDT can be used in both goats and sheep. Okay, let's talk about complexity. Now, complexity can occur especially when vaccines are being developed. For example, when vaccines are first in the beginning stages, The degree of weakness, for example, should the strain be killed? Should the strain be just weakened or aged? Or should the strain be heated? All of those ideas and concepts will have to go through experimental stages to determine what is the best route in developing this vaccine. You know, if the